Guys, and welcome to a quick video on how to do COVID population modeling. You're going to want to make sure you have your packet, your COVID website with countries under cumulative cases and the relative to population clicked off, and you're going to want your exponential growth spreadsheet. Now, the first thing you're going to do is you're going to calculate R for 3 countries that are experiencing COVID growth. I did September 9th to 10th here, which is 40, or I should say September 10th to 11th, 40.96 million to 40.102 million people for the United States. And if you do the math, or if you put those values in your spreadsheet, you'll get a growth factor of 0.005895. You're going to want to make your intrinsic rate of growth that value. And you're going to want to make it be applied to all future populations. Now, the question that you can ask with this modeling is, what will be the future population of the United States in terms of COVID cases if exponential growth continues at this rate? So I'm going to make a prediction about what the population should be on September 25th, given that growth rate. You'll notice in this database that if you make 40,960,000 your population, you apply this growth rate, you're going to be adding this many people, and here's your new population at the end of the day. And this new population on day 2 will have the same growth rate. So what I need to do is I need to go down to the 15th day, which is September 25th, and it's predicting that I would have 44,966,000 people. That is comparison to 42.90. That means that I slowed substantially. So when I talk about the number of people that I expected versus predicted, on September 25th, I expected to see quite a bit more people. I'm going to put that value in there. And when I look at the difference in my exponential growth model right here, you're going to want to do the difference between your value that you see in the graph and this value right here. So I can click on F18, or you could type this, and I have a difference of this many people. It looks to be around 222,000. So again, with the exponential model, you're going to solve for little r using math or this formula. You're going to put little r here. You're going to put in your base population for day 0. And then you're going to see how many days your population would grow exponentially at, what is your predicted value, and what's your actual observed value on the graph, and what was the difference. You can do this also with your logistical model growth, the difference being that you're going to apply a value of k. So when I look here at this exponential model of the United States, I really don't see a carrying capacity yet for the United States, but I do notice that earlier on there was one logistical model where we exponentially grew and then curved off between 10 and 30 million. So maybe the United States is going to follow a similar pattern where we're started at 30 million and we're going to grow until we get to about 50 million cases. So that's where I could then come down into my second sheet and specify that I think the United States is going to achieve 50 million cases on November 1st. It's going to take 69 days from the day that I measured it. So when I go into my modeling sheet and I go to the second sheet, which should be at the bottom. I'm not sure why it's not showing on here. Apologies, there should be. I can see it right there. There it is, logistical growth. You're going to do the same thing where you're going to be putting in a base population. So this would be 40,960,000 people. I know that the growth rate of intrinsic is 0.00585, but I'm going to make the carrying capacity 50 million. Now what that means is that my per capita growth rate is still pretty high. Notice that earlier on, if we had a value very far from the carrying capacity, we might be at a value of 1 because we aren't approaching the carrying capacity. But this does mean that we're still adding many, many people. So what I need to do is I just need to bring this down, and I also need to bring my number down to about 69 days because I am going to be calculating the growth rate of my population for 69 days. Notice I'm clicking and dragging, so what I'm doing is I'm highlighting some data and I'm clicking down. You might be doing this for a smaller value in terms of numbers of days that you're looking at, so if you need help again with your spreadsheet, let me know. 50 million, you're going to go all the way down to this because the carrying capacity never changes. The per capita growth rate is always going to be relative to what is the current population and what is that. The added population, we are going to apply the formula all the way down. And then finally I need to do the added population in terms of this. The only thing that really changes every single data point is what is the added population. And there we go. If you notice, we keep going down. As we get closer to November 1st, the per capita growth rate continues to slow. And this is because we're thinking about what is the current population relative to the carrying capacity, and how does that change the intrinsic rate of growth. So we're going at 0.18 to 0.16, and we're going down from 43,000 to 39,000. And we continue to see that change as we get closer and closer to November 1st. We're now at only adding 33,000 cases. This should give you some caution in terms of thinking about things like population growth or COVID or other viruses. The fact is that it takes a long time for cases to slow. It does not take a long time for growth to occur, but generally populations are more resistant to slowing down growth than they are to increasing growth. I can do the same thing here where I can talk about the actual population of infected cases versus where I thought it would be. So I was expecting that given the growth rate of COVID that we would be at 50 million cases. We're only at 600,000, so that is a positive thing. If you're looking at your data and you're unsure of how to figure out the carrying capacity, you can easily make a number up. So maybe India is going to reach carrying capacity of 35 million, and looking at this axis, it might be October 15th. You're just wanting to do the same thing again where you are inputting your base population, the intrinsic rate of growth that you calculated, what you think your carrying capacity is, and then how many rows of data do you need to get to that final date. I will be at school at 7 in the morning tomorrow to help you with any issues that you have. You do not need to worry about completing the R versus K selected section. Have a great Monday, and I will see you soon.